you got?
So which one is the x and which one is the y? Is the number on the bottom?
So I'm gonna have you figure that out. Okay, so what is the direct variation equation, the generic equation? Y equals ax. All right, so somebody solve for a. What am I going to do here to solve for a? Rita? Not y equals. So if you're not sure what the order is, go back to the direct variation equation like format and solve for a. Okay? So it's a great question because you do need to know that, right? So it's always y over x. So my coordinate point here would be 3, 4, which is kind of counterintuitive, right? Because we usually read from top to bottom, but then, and we also read from left to right, but that's not the order it's in. So the top is always y. So if you think about slope, slope is rise over run, the change in y over the change in x. So it's y over x. So it's very similar to your slope in that way, that your numerator is always y, change in y, rise. Your denominator is always run, or your change in x, or your x. Does that make sense? So if you kind of keep that in mind and attach it to slope, because I know you remember that slope is rise over run, or change in y over change in x. That'll help you keep that track of that too, okay? You're welcome. Are there any other ones? Giselle? Okay, so I have this. So we're going to add a negative 8x to both sides. So I end up with 2y is equal to negative 8x, okay? I mean, you can have plus 0, but when you're adding 0 to something, the 0 just goes away, right? All right, go ahead. What were you going to ask? Isn't that what I have here, my child?
Oh, sorry. And then, are you allowed to, divide?
Well, I have to get this in the form of y is equal to a times x, or y equals mx plus b. I'm trying to determine if it's direct variation or not. These are my two options. If it's not direct variation, it's slope-intercept, which means I have something other than 0 being added to my x term. Or if I have direct variation, I just have y equals my x term. So that's what I'm kind of comparing, is which format do I have this in. Since I have plus 0, it's going to be my direct variation. But the thing is I need to get my y alone. How am I going to get my y alone? Yeah, I've got to divide everything by 2. If this was a constant, if this was like 1, I would divide it by 2. And this would be y is equal to negative 4x plus a half. And that would not be direct variation. That would be slope-intercept. But here, because this is 0, I mean, I can say divide that 0 by 2, but that's still 0. And I don't need to see plus 0. So this is simply y is equal to negative 4x. And that is a direct variation. Yeah, absolutely. What else can I do for you guys? Okay, put this away. Let's talk about how else we see direct variation. So today we're focusing, we did skill stuff yesterday just so you understand, or Thursday, just so you understand how direct variation equations work and their graphs. Now we're going to talk about tables and story problems. All right, so we're still in 3.6. So 3.6 continued. We're talking about direct variation. All right, when we talk about functions or equations, no matter what type of functions that we're looking at, whether we're looking at slope-intercept form, direct variation, there are 3 ways that we can show them. 3 ways to show. This is just kind of a review. The first way is through an equation. The second way is through a table. And the third way is through a graph. All right, so today we're going to be talking about tables. But then we're also going to be talking about story problems. So let's first talk about direct variation tables. All right. Do you guys remember when we were beating up tables for slope-intercept form? What were we doing? Who remembers what we did to beat up a table for slope-intercept form? So let's do a quick review. Let's say we have x, y. I'm not going to do a whole thing. So let's say we have 1, 2, 3, and we have 5, 10, 15. How do I beat this up for slope-intercept? To see if it's a slope-intercept. To see if it's linear, and I can write a slope-intercept equation for it. Giselle? So change in x, change in y, because what are we looking to determine? And then y, what are we using them to find? We're looking for slope. So this is our focus, is our slope. And slope is my change in y over my change in my x. How many of you guys remember doing that? Right? So we would do like 2 minus 1 is equal to 1, 3 minus 2 equals 1, 10 minus 5 equals 5, and we're going to keep going. So my first slope is going to be 5 over 2. My second slope is 5 over 2. So what we've now proven, we've proven the table is linear. All right, and then we could write an equation for it. I mean, the only thing missing here is our y-intercept, and we could figure that out. But I just wanted to focus on beating up the table. Yes? 2 minus 1, 3 minus 2. Oh, this should be a 1, sorry. Thank you for correcting me, Carmen. This should be a 1. Thank you, sweetie. I'm glad you're paying attention to that. Thank you. So my slope for both of them would be 5. Thank you, sweetie. All right, so let's talk about direct variation tables. So for me to write a slope-intercept equation, we need slope. All right, so we found our slope. We could keep going and write an equation for that. We would have to find our y-intercept, etc. All right, the reason I'm saying that is for us to write a direct variation equation, what is the one thing I need to determine to write a direct variation equation? For slope-intercept, we need slope and our y-intercept. What do we need to write a direct variation equation? Come on, you guys should know this. Y equals A times X. What do I need to be able to write a direct variation equation? Joseph, you need the A. You need the A value. All right. So we are to determine if we have a direct variation table. All right. We just need to see if all the A values are the same. So direct variation table. We need to determine if all the A values are the same. So that's what we're looking to find. If they are, we have a direct variation table. We can write an equation for it. You guys with me so far? This is a lot easier math than the slope-intercept, because it's a little bit more math on slope-intercept. All right, so let's figure out how we do that and what the structure of that's going to look like. So let me give you guys a table. Alright, so let's say that what we're doing is the table below shows the cost of downloading songs from an internet site. Alright, C is the cost and S is the number of songs. Now we can certainly change that to X and Y. Alright, here's our table. So we have number of songs and we have total cost. So here's our S, here's our C. Alright, if you want to change that to X and Y, you can. How do I know what I changed to X and what I changed to Y? How do I know which one would be our X and which one would be our Y? Lily? What do we know about all tables with X and Y? Yeah, my Y is my Y. Say that again. Yeah, so Y is our dependent info and X is my independent info. Your X is always your first column, your Y is always your second column. My X is always my first column, my Y is always my second column. Alright, that's also something to remember, but I like how you said it better. Your dependent is always your X, your independent is always your Y. Alright, so for 3 songs, it's $2.97. For 5 songs, it's $4.95. And for 7 songs, it's $6.93. Alright, so what I want to do, I can imagine you know what I'm going to say to you. I want you to set up a third column, and it's going to be for your A, which is Y over X. So I want you to create a third column. And it's for A, which is Y over X. So I'm just going to put my Y over my X. So I have 2.97 divided by 3. I have 4.95 divided by 5. And I have 6.93 divided by 7. And then I'm going to find what those mean. What those end up being. So if you grab your calculators, 2.97 divided by 3 gives me 0.99. And then I'm going to see if the rest of them are exactly the same. Because they need to be the same for this to be a direct variation table. So if you notice, these are all the same A value. So A is equal to 0.99. What does that mean? What does that 0.99 represent? Think about what the information for Y is. Think about what the information for X is. What does 0.99 mean for us, Seamus? Exactly, that's a cost per song. Alright, so since these are all the same A value, this is a direct variation table because they're all the same Y value. Alright, so what would be the equation for this table? Remember, Y is equal to A times X. What would be the equation for this table? Carmen? Just substitute the A in. Y equals Excellent. There's my equation. That's it. All right, so to determine if a table is a direct variation table, you just set up that third column. All right, you find your A values for each of them individually, just like you did the slope. If they're the same, it's a direct variation table. All right, I want to show you one more, and then we're going to move on to story problems, okay? So I want you to write this table down, and then I'm going to give you the things I want you to answer with regards to this table. So go ahead and write that down. I'm going to write it down, and then I'm going to put the questions up there that I want you to be able to answer. And you can always change these x and y. You do not have to change them. You don't have to use their variable. So the first thing I want you to do is explain why. Okay, so write this down, and then I'm going to talk to you. Don't do anything else yet. Okay, so let me write this table down real quick. I have 3, and then 25.77. I have 6, and then 9, 51.54, and 77.31. Okay, there's a phrase here that I want you to recognize. Y varies directly with X. That phrase indicates that we have a direct variation. So in part A of this, I want you to explain why the cost varies directly with the number of DVDs. Y varies directly with X. So obviously Y is my cost. There's the varies directly with. X is my number of DVDs. We're going to get more into this phrase when we do some story problems. All right, so what I want you guys to do first is I want you guys to explain why we can say in this table the cost varies directly with the number of DVDs. So what that means is you need to determine if this is a direct variation table. All right, so what this means is you need to prove this is a direct variation table. So go ahead and start doing that. I'm going to put the second part of this up. All right, so those are the things right there that you are doing right now. When you make that third column, write A is equal to Y over X. It's going to be helpful for you to kind of have that focus. So the first part is, after beating up the table, you're going to explain why the cost varies directly with the number of DVDs. Then tell me what the constant variation means, and then write an equation for the table. Alright, so what did you guys get for your A values? What did you guys get for your A values? Ashley? For all of them? Awesome. So Ashley, why can I say that this is a direct variation table? Or why can I say that cost varies directly with the number of DVDs? Yeah, I'm going to say because they all have the same A value, or constant of variation. What does my A value or the constant of variation mean? Maya? Yeah, it means it's $8.59 per DVD. So that's what that means. It's the cost for the DVD is all the same, and they're all $8.59. All right, so somebody write my equation for me. Somebody write my equation for me. Natalie? Write my equation. Excellent. Y equals 859x. How many of you guys are cool with tables? Okay, so let's talk about story problems. All right, so let's focus on story problems. Again, I'm going to say the same thing. All right, so story problems. Whether we have a graph, we have a table, or we have a story problem, we only need to determine the A value to write a direct variation equation. Keep that in mind. All right, the other thing to keep in mind is Y varies directly with X. Keep that in mind. That's going to be really huge when we look at these story problems. All right, so I'm going to show you the story problem. I want you to write down this information. We're going to read through it together so you can kind of focus on the right information. Somebody don't read what you're looking to find, but just read the problem for me. Go ahead, Giselle. Okay, so how many of you guys see that sentence in there that says something varies directly with something? Write that down. At least write that phrase down. Number of tablespoons of sea salt varies directly with number of gallons of water. That's really important because that does two things. That first of all indicates that we have direct variation, and secondly, it tells you what your X information is and your Y information is. What also do you notice they've given you? Other than that statement, what do you notice that they've given you as well? Lily? Yeah, they give us a relationship between tablespoons and gallons. That will always be the case. They will give you a data point. All right, so let's make sure you write that down. All right, what do I need to be able to write a direct variation equation? By the way, I would change this to X and Y, just so it makes sense to you guys with the constant of variation. That's my opinion. What is the only thing I need to be able to determine to write a direct variation equation so I can do that first part? Rita? The A value. Remember, A is always Y over X. So, finish this problem. Work together on this. identify your x and your y, please. Always do that before, even if they've given it to you, write it down. Always identify what your variables stand for. So remember, y varies directly with x. So you guys, identify your x information, identify your y information. So somebody tell me, what is my x information here? Remember, y varies directly with x. Number of tablespoons varies directly with the number of gallons. So what is my x information? What is my y information here? I know they gave us S and W, but I don't want S and W. What is my x information? What is my y information? Lily? Excellent. Yep. How did you know that? Exactly. All right, so make sure that's a really important thing to write down is that statement and recognize that y varies directly with x. Okay, so now that I've figured that out, what does my data point look like? So here's my data point that they've given me. It's one relationship in this. What does that look like as a coordinate point? So somebody write this, 100 tablespoons for 20 gallons of water. Somebody write that as a coordinate point for me. Rafaela? 20, column 100. That's really important to get that order correct. So now, how do I find my A value? How do I find my A value? Because that's my first thing I have to find. Seamus? Y over x. So Seamus, what is ours? 100 over 20. And what does that simplify to? Yep, that's 5 tablespoons per gallon. So now, Seamus, write my equation for me. Y is equal to A times x. So what is that? What is that equation? At 5 times x, right? So always write the equation first. So the first part was write the equation. The second part is now use the equation to find the amount of tablespoons for 30 gallons. So always write that equation first. What variable is my 30 gallons going in for, Seamus? What variable? That's my x. So don't forget to make sure that you know exactly what variable you're substituting in for. Because I could have said, I've got 10 tablespoons of salt, how much water do I need for that? I could have done that as well. All right, so I have y equals 5 times 30. So how many tablespoons do I need, Seamus? 150 tablespoons of salt. And then I'd write that as a sentence. I need 150 tablespoons of salt for 30 gallons of water. So the key to direct variation equations, quite honestly, I think are a lot easier than slope-intercept form. All right, if it's a table, you're beating up the table to figure out if all the A values are the same. Okay? If you do, all you needed was the A value. All right, in a story problem, you're looking for that phrase, something that varies directly with something. If it does not say that, it's not direct variation. Remember, slope-intercept is y as a function of x. That is slope-intercept form. Y varies directly with is direct variation. All right, once you do that, you're just looking for your, know what X and Y are, you're looking for the one coordinate point, find your A value, and you're all done. Okay? Yes? Because you need to know which one is your X and which one is your Y. Like, I just want you to focus on figuring out which is your X and figuring out which is your Y, which is why I always want you writing down what X and Y stand for, so you're thinking about it. I want you to write as a coordinate point, so you're thinking about it, because as Natalie, we talked earlier, it's really easy to switch your X and your Y. It's super easy, and if you flip-flop your X and your Y, you're not going to get your A right. So it's just one extra step of you being like, okay, what is this thing as a coordinate point? Right, you could, instead of doing that, you guys sit still for a second. What you could have done, instead of writing as a coordinate point, you could just go like this, and write X underneath that, oopsie, write Y underneath that, and X underneath that. That's fine with me as well. Just identify which of those in there is your X, and which of those is your Y. You know what I mean? So whether you want to write as a coordinate point, or you want to label it, I don't really care. Just figure out which is which. You know what I mean? Okay. You guys can go.